So, in 2-4, we will be solving right triangles, but we're going to start off talking about significant digits. Do you know about significant digits, perhaps from a science class? No? Yeah, sig figs. Yes, maybe. Rings a little bit of a bell. Okay, well, basically, it's how do you know what place to round to? Usually, in math, we just tell you, right? But if I'm doing a problem, say you have your own company, right? No one's going to tell you, round to this place. Like, it's up to you to know. So one way that we know is by using significant digits. So basically, if I'm working on a problem and one of my values has 2 significant digits and the other one has 3, my answer can only be as precise as the fewest number of significant digits that I have. Does that kind of make sense? So my answer should be rounded to 2 significant digits if I only had a 2 and a 3. So first of all, what the heck even are significant digits? So basically, they're numbers that are important that I couldn't, not that they're not all important, but it's basically how precise is my measurement. So I actually want to start with this one. It's different than scientific notation, right? All of these numbers here are there for a reason. They're holding its place. What about this one in front? Do I need that one? No, I don't need that one, so that one's kind of irrelevant. But these other ones I do need. So this guy has 4 significant digits. So that means my answer, if I were doing a problem and that number was in it, should have 4 significant digits in it. Yeah, okay. So now, let's look at the next one. This guy, he's got all of these. What about this one? So, a lot of times you would think, no, I don't need that number. You actually do. This tells me that I've measured this far out accurately. So that one is going to count as a significant figure. Let me try and give you another example. If I say something weighs 1 pound, right? Does it weigh exactly 1 pound or could it be 1.1 pounds? Well, and I just rounded. It's unclear. If I wrote, hey, the measure of, let's take my brother's child that still hasn't been born. We were hoping for a leap year baby. Didn't happen, right? Let's just assume that this baby is born today and she ends up being 8 pounds, right? Exactly, like on the nose. I'm going to write it as 8.0 because that lets you know it's on the nose, right? If I go to the store and I just buy 8 pounds of apples, right? Maybe it was 8 on the nose, but maybe it wasn't. If I just come home and my husband says, how many pounds of apples did you buy? And I say 8 pounds, right? Maybe it was 8. I'm not going to come home and say 8.1. I'm not going to come home and tell him how many pounds of apples I bought anyway, but just pretend, okay? So there, I would just be rounding. It doesn't really matter. Just like, yeah, it's 8 pounds. Okay, whatever. So if I just wrote 8 without the decimal and the 0, then I'm saying I've rounded to 8. If I give the answer with a decimal, that tells me, okay, I actually measured out that far and the weight was actually 8 on the nose. Does that kind of make sense? Okay. Same thing if I measured out 8.01. That tells me I've measured out even that much further. So this is an even more precise answer. So this guy would have 3 significant figures, this guy would have 2, and this guy would only have 1. Kind of make sense? Okay. All right, so now let's look here at this one that was 3,000. Notice there is no decimal. This guy has only one significant digit. Only one. Whereas the next one that has 4,000 with a decimal place, this guy has 4. This is like someone says to you, oh, how much money do you have in your bank account? And you're like, about 3,000. So maybe I have a little more, maybe I have a little less. I'm rounding to the nearest thousand in that case. This would be, I literally have $4,000 to the nose in my bank account. Yep.
Wait, so the 1.3,000, does that have like 5 significant?
Yes. Sorry, I never put it down. What does this one have? How many significant digits would you say this guy has? 5. They all count. Everybody. So I guess, actually, I'm going to modify my example a little bit. This is, oh yeah, I have about $3,000 in my bank account. This is, I have 4,000. Maybe I have 4,010 cents. Whatever, but I'm just calling that 4,000. This is literally $5,000. Maybe, I guess you could have like 2 cents. That would round off. So, jump all the way back to the very first one. How many does this guy have? He's got 4. They're all, it's the zeros that could go away. That 0 can't because he's in between 2 other guys that are important. So that one's got 4. Okay, so if I go to, let's look at example number 1 here. Solve right triangle ABC with right angle C if B equals that and A equals that. So, first, let's make sure that we label our triangle correctly. I have a right triangle and I know the right angle is at C. Which one's A and which one's B? It doesn't matter. What does matter is where you put, so angle B is 28 degrees 40 minutes. Where is little a? Little a is 25.3. Is that this, or this? Where is little a? Yes. Remember, the lowercase letter is the side that's opposite that angle. So this guy's lowercase a, this guy would be lowercase b, and this would be lowercase c. Remember that? Okay, so now I know, since they're giving me lowercase a, that's down here, and that's 25.3. Now, the directions say solve the right triangle. Huh, what does that even mean? Well, it just means find everything else. Find all the other angles and all the other sides. So that's what solving a right triangle means. Now, luckily, there's only one more angle that I have to find, and I can find it. How would you? You can. You can. So all 3 angles have to add up to be 180, right? I don't know what this one is, so I can call it x. So I can add 90 plus x plus this equal 180 and then solve. Or you can save yourself a teeny bit of time. If that one's 90, don't these two have to also add to be 90? Right? So I could just add these two together and set equal to 90. We're doing the same math, but instead of adding all 3, make it to 180, I can add just these two, set equal to 90. Basically, I need to do 90 minus whatever this is, and that'll get me that, right? Well, I have the minutes and seconds. So, yeah, you could do it 90 degrees minus 28 degrees, 40 minutes, or, yeah. And then borrow. You could do all this. What else could you do? Yes! The calculator. We know how to do it now. So let's just do 90 degrees. Do you remember how to get degrees? Oh, you guys don't even have calculators. You should grab yourself one.
Just sitting here waiting for you.
Who can remember how we got degrees and minutes and seconds? Where did we go? Yes, if you look at that button diagonally down from the green second button, see it says angle? You want to access that menu. So we want 90 degrees, and we're going to minus 28 degrees, 40 minutes. Okay, and then do you remember how to change that into degrees, minutes, seconds instead of a decimal?
Second angle,
Yeah, second angle, and then you scroll all the way down to choice 6. Do you get what I got? So, I don't need the 0 seconds because just 0. 21 degrees, 20 minutes.
Wait, that's it? I just did second angle DMS next one. It's like saying like DMS 1.
Did you get 61.33333?
Yeah.
You scrolled all the way down to number 6? Let me see.
It's just saying like DMS.
Let's clear this. I don't know what's the matter with it. Second angle, choice 6. I don't know.
Oh, sorry. Okay, thank you.
You're welcome. Okay. So now I have angle A, 61 degrees, 20 minutes. And the other things we need to find are the lengths of the other two sides. How? How would you find the length of, I don't know, let's say this side? I'll give you a hint. You know how to do this. I'll give you another hint. I know you know how to do this. Okay, fine. One more hint. SOHCAHTOA, people. Can't you use the trig ratio? Of course you can. So, I have these two sides, opposite and adjacent, so I'm going to use tangent. Thank you. So tangent of 28 degrees 40 minutes would equal opposite x over adjacent 25.3. So now I just asked Mr. Calculator to do the heavy lifting. I get this. So now, this is where the significant digits come in. How far out am I going to go? Well, since this guy only has 3 significant digits, that means my answer can only be accurate to 3 decimal places. Or, I'm sorry, 3 significant digits. So, if I have this crazy decimal, and I'm going to round this to 3 significant digits, what would my answer be? Am I going to make it 13.83222 and round it all the way out over here? No. 13.8. That answer would have 3 significant digits in it. Just like the smallest amount that I have. So I'm going to give an answer of 18.3. Bless you. Now, that's just that side. I also need to find this side, the hypotenuse. What? Oh, yeah. I just swapped them on accident. 13.8. Thank you. I still need to find my hypotenuse. Here's what I would advise you not to do. You know 2 ways to find your hypotenuse. You could use Pythagorean Theorem. You have 2 sides, right? I know what x is now. You could do a squared plus b squared equals c squared. I would advise you not to do that, though. It's not wrong, but the problem with doing that is that, remember, this is a rounded answer. So now you're going to take a rounded answer and plug it in, and now this one's going to be that much more off because that number was rounded. And what if you messed up doing this? Like I just did, right? I had 18.3. So even though I know I did the math right, I just wrote the number down wrong. If I use 18.3 to find this number, I automatically have that number wrong now. So I would advise you to not use an answer that you just got if you can avoid it. If there's another way for me to use the numbers that they gave me, that I know are right, that I couldn't have messed up because they're the ones that are given, I should do that. So I should. Why don't I just do another trig ratio using the 25.3 and the 28 degrees 40 minutes that they gave me? So why don't I just do adjacent and hypotenuse would be what ratio? Adjacent and hypotenuse. Cosine. So let's do cosine of 28 degrees 40 minutes equal to adjacent 25.3 over hypotenuse is going to be y. Now I can go ahead and solve. What do you do when the variable's in the denominator, by the way? How will I actually solve this? Let's try just for a minute. We'll come back to this in a second, but let's just do a simpler one. What if I had like 6 equals 5 over x, and I wanted to solve for x? How do you do that? No. I mean, you can't. If you multiply both sides by 5, this is what you get. You'd get 30 equals 25 over x. You didn't make your life any easier. Okay. Thank you. Julia, special delivery. So you can multiply by 1/5. And it makes your life a teeny bit easier, but not by much. So let me show you. Go back to what I originally had. 6 equals 5 over x. If you multiply both sides by 1/5, so on this side I get 6/5. On this side the 5's will cancel, but I still have 1 over x. So I'm still not done yet. Well, you could get something from here now. What could you do to finish this? What? You could. If you have an equation, you can take the reciprocal of both sides. So I could literally just flip both sides over and get 5 over 6 equals x over 1, or just x. So that works. I get there. I eventually get an answer for x. Okay? Allow me to show you a much faster way. If you have a proportion, actually, let me start with maybe not even this one. Let's just say any proportion, which I don't even know if you remember what a proportion is. That's just 2 fractions that are equal to each other. I know this guy's not a fraction, but couldn't you just put him over 1? Right? And now it's a fraction. So he still counts as a proportion. So proportions have a fraction equal to a fraction. Did you know that, yes, you can take the reciprocal of both sides, so b over a will equal d over c. That's absolutely true. Do you even believe me? Don't take my word for it. Let's try it. So give me 2 fractions that are equal to each other. How about 1/2, and give me someone that's equal to a half? 2/4. Okay. If I took the reciprocal of both sides, is it really still equal? Well, let's see. 2 over 1, is that really equal to 4 over 2? Yes. Okay, so proportions, you can flip both sides. That's important to remember. But here's what's super convenient and will be very useful to you. What you can do, if I start off with 2 fractions equal to each other, you can swap either diagonal. Or both diagonals if you wanted. What? So my claim is that, let's say I want to swap those 2 diagonals. I'm claiming that A over C will equal B over D. What? Let's try it with the same one. So this is A, B, C, D. So if I did A is 1 over C, is that equal to B, which is 2, over D? Well, Miss Sabia, that only worked because they're both 2s, so it's not going to work again. Okay, well, let's try a different fraction. What if you did like 1/3 being equal to, I don't know, 10 over 30? Right? That's a true proportion, right? 1/3 is equal to 10 over 30. If I swap one diagonal, now I'm saying 1 over 10 is equal to 3 over 30? That is true. Okay, wait, swap the other diagonal. I don't believe this. Okay, let's swap it. So if I did this one instead, 30 over 3 is now going to be equal to 10 over 1. If I swap this guy. Isn't that still true? So my point is, you guys, go back to one like this. You're allowed to swap a diagonal. So that means without really even doing much math, I just get x equals 5, 6. I'm just swapping those 2. So when I hit a problem like this, I know I can just swap these 2. So y is just going to be equal to this divided by this thing, because I'm just going to swap these. It makes my life so much easier. Swap those diagonals, just boop. So now I get y equals 25.3 divided by that crazy thing. And that will save you so much time and hopefully stop some of you from getting it wrong by doing the wrong things. Because a lot of kids will solve this, but then they'll have the variable in the denominator still. They'll solve it and have it equal to 1 over y, but not y. Anywhoosers, I'm here. So now I just asked Mr. Calculator to do all that math. I have to sneeze. Maybe it'll go away. Okay, 25.3 divided by cosine 28 degrees, 40 minutes. Yes, I get 28.8. Did you? Right, and then I have to think about how far should I be rounding this out. My answer should have 3 significant digits, so the 28.8 makes sense because that would have 3 significant digits as well. 28.8. Cool. Centimeters, I guess we're in. You with me? I feel like you guys are a little lost today. Let's try example 2. Okay, first of all, let's label our triangle. C is the right angle. Doesn't matter where you put A and B, but once you put them in, you're locked in, right? Okay, so I did it like that. So go ahead and label the side that would be lowercase b as 55.87. So if you have your triangle labeled with ABC in the same way that I do, that means that lowercase b should be right here, 55.87. That side. And the side labeled little a should be, bam, right here. That's the 44.25. Okay? The lowercase letters mean something. It's across from that big angle. All right, and they're saying solve the right triangle. So, looks like I'm going to have to find the third side and both angles. I don't know what either angle is. Golly gee. Well, why don't we start by finding the hypotenuse? How? I can't do a trig ratio without an angle. How will you find the hypotenuse this time? Yeah, this time I'm gonna do the Pythagorean Theorem. They gave me two sides. Let's just pop them in. We'll ask Mr. Calculator to do some work for us. Don't forget to take the square root of both sides. So I get this crazy number. Now, how many significant digits should this answer have? 4. Because if you look at the problem, the ones that I have, both of them have 4. If one had 4 and the other had 5, I'd have to go with 4. Whoever has the least. So, but they both happen to have 4, so my answer should have 4 also, which means that my answer is going to be 71.27, and that's as far as I'm going to go. So C is 71.27. All right. Now, I do need to find angle A and angle B. It doesn't matter which one I find first. Let's say I wanted to find angle B first. How? How do you find this missing angle?
Of sine.
Yes. This is where I use second sine, cosine, or tangent because I don't know what the angle is. Now, again, I would advise you to try and not use this value that we just came up with. Because what if I'm wrong, right? I can do it without using that number. Let's use the two numbers that they gave me, because I know that I didn't mess those up because they're given to me. So if I wanted to find angle B using these two numbers, what ratio should I be using? Tangent, because that's opposite and adjacent. So I have tangent of my missing angle, I'll call it theta, equals the opposite over the adjacent. And now I should be able to do that on the calculator, right? What are the series of buttons that I hit? Second tan, and then I just put 55.87 divided by 44.25 right in those sets of parentheses. I got that crazy number. Did you? And significant digits, I'm going to go out to, I want 4 in total, right? So that means that this answer would be? It's 51.62, correct. So now I have angle B. Actually, so maybe I shouldn't call it theta. I'll call it B just so I keep organized here. Because I do still need A. So I have some options. I could go ahead and do a ratio again using these two sides, but angle A, right? So I know angle A would be tangent of 44.25 over 55.87. I do know, since that's 51.62 though, couldn't I just subtract it from 90 and get this? I'm fairly confident that I didn't mess up on B. But you do roll the dice a little bit if you just do 90 minus angle B. But actually, it's a really good way to check yourself too. So if I just do 90 minus that, that means angle A has got to be 38.38. But if I wanted to double check myself, I could do second tangent, it'd be 44.25 over 55.87. Well, what do you know? 38.38. So now I'm super confident on my value for angle A. All right, so solving right triangles. Make sense? Okay, so we'll stop there. After lunch, we're going to talk about angles of elevation and depression.